Hey, everybody. This is Mark Smith and David Conley, your hosts of Digital Roughnecks.
I'm back.
You're back, man.
I'm
And we're here with our favorite director of AI, Mehdi Korjani. Hey, welcome back, Mehdi.
Thank you for having me.
Yeah, the last episodes were perfect because you explained a bit, I would call them like machine learning 101, okay? Well, one of the subjects that's come up recently, in fact, I've had conversation with you, is this whole idea of deep learning. And I thought it'd be important because I think people throw that term around and they really don't know what it means. It's another one of those things like AI, just another part of the magic. But as it turns out, it's actually science. So how do you explain deep learning for people who, are new to this whole AI thing?
So deep learning is not a new concept. They rebranded from the neural network, and the neural network is very old concept that people try to use it, and the whole concept is coming from the brain structure. So in the brain you have a synapses, and then you have some neurons, and then these synapses connect to each other, and then they generate some output, and then you start feeling something or understand something. The simplest portion of the neural network in the machine learning, they call it node. And then if I want to briefly explain the node, you have some input, give them some weight, and then sum all of them together, and then that is your output. Right. So you have that very simple node.
You can weight nodes.
So you have some input. Like, to give you an example, right? So you want to find the price of the house, right? So you have some of those inputs about the house. Okay, what is the size of the house? What is the, for example, number of the bedroom or number of the bathroom or the locations, right? So these are the input, and then each of them may be different, right, in terms of the importance, and those are the weights. So, for example, you say that the size of the house has more weight compared to number of the bedroom, right? And then that is a very simple model. You give them some of those weight, and then sum them up in order to find out, okay, this should be, for example, the price of the house, right? So very simple model. People call it regression model. So because that is a combinations of the summation of the input times some weight. The neural network is when you have this simple node and then you put it together in the different structure. You can put it into the lots of different structures and then come up with the different neural network. And then they have people call different one with a different name. Back to 2006 or 2010, we couldn't put so many of these neurons together, maybe 1 or 2 layers, maybe 10 of them, 20 of them. Right now, the order is in the billion, right? So you have much bigger network with much more neurons. And then you put it all of those together, a little bit change in the math, but that the same thing, they call it deep learning. Right, because you have much wider and more complex model. And then all of those parameters that I explained, that, for example, you have, you want to predict the price of the house, so you go to the agent and the agent say that, okay, maybe the size of the house is more important than for example, number of the bedroom. But you can go to the lots of different people and then ask them and then create some knowledge base.
Mm-hmm.
The good thing about the deep learning is that it can learn from the data. You can integrate all of those informations about all of the houses, for example, in United States, you know the price, and then you create a model, and the model will figure out what would be the best weight that gives to the size of the house, to the number of the bedroom, to the location. So that is what we called the machine learning. The machine learn all of those parameters and then give us back to us in order to estimate the price of the house. So when the new house is coming to the market and then we don't know the weight, we don't know the price, we just give it to that model, with all of those informations about that house, and the model estimate what would be the price of that house, right?
Okay.
And then that is something that you can see, for example, in the Zillow or Redfin. They're
Mhm.
doing some estimate, and the estimate is very close to the actual price of the house.
Right. Okay. Makes sense.
What's interesting, Mehdi, taking that to the next level, computer vision. Okay, that's when you're using, input from images, or camera or whatever, might actually improve that deep learning model significantly, because you could have two houses exactly the same size and everything. One's on one side of the block. Let's say it's on the ocean side of the block.
Mm-hmm.
And the other one is on the other side and so if you were to look out of their front window and see a view, one of the ocean, the other one of a street and somebody else's house, if the machine learning could learn and say, hey, that ocean view, that's worth, I'm going to give that away times 10. And I'll give the other one the street view with, and then of course the other one will be an audible learning. Like if it could literally have a microphone and listen to the street noise. And one, you're hearing ocean waves. The other one, you're hearing cars going by, on PCH and Harley Davidson's, engines. And you're like, okay, I hear lots of that, price goes down. I hear ocean waves, price goes up. So there's two issues, which I suppose, I don't know if Zillow has those parameters, but
Yeah.
if the deep learning model could actually look at the image of the view and hear the street sound, it would dramatically change the price.
Yeah, for sure. So, I don't know about the models that they have, but they have a term in the machine learning community. They call it structured and non-structured data. So the structured data is what I explained at the beginning. You have some features about the house, and then you can put it into the table,
Right.
right? So those are the structured data, and then people in the back, I don't know, maybe a couple of years back, they mostly use the structured data. They have to get the data, put it into that tables, and that table can be used in order to train the model. Right now, if you look at all of those things that you're talking about, the images, the sounds, right? Even the videos, those are unstructured data, even the text, right? So these are unstructured data. You cannot put it simply into the tables and then use it to train the model. So there is a term for that, and then deep learning model can handle both of them, right? So it can handle both structured data and non-structured data in order to better estimate the output.
It's incredible. So you're literally creating. I mean, you even use the word node and neural network, and so you're literally creating a brain that understands a specific task and can handle information in
Yeah, so
large swaths.
they call it general AI, or something that can do multiple tasks at the same time, right? So there are some breakthrough recently in the recent year through the general AI, but generally, all of those tasks that I'm saying is that one specific model for one specific task, right? So if you have it for the price prediction of the house, you cannot use it for example, writing a text, right? Recently, for example, if you go there and then look at the GPT-3, this is a very big model by OpenAI that they release the result, and then that model is capable of doing multiple tasks at the same time. Can answer the question answering. It can generate the story for you. It can write, for example, even some code to create a website, right? It can
Right.
do the calculations of the some numbers, all of them through the one model, and then that is one step closer to create general AI. But so far, everything is a specific model for the specific task, and then people try to improve the model and the accuracy of that model in order to solve only one specific task.
So with Clean Connect, we're building a stack of models, right? That are single use case models. So is what you're saying in the future? Eventually, we can put all of those together in a single operational intelligence model that literally you can plug it in and there you go. It understands all the data coming in. It can manage that well site autonomously.
Yeah, it could be, right? But
Right.
you have to give it, I think, maybe 5 to 10 years
5 to 10 years.
to get
Okay.
there. Yeah.
That's crazy. You know, that's a huge deal for sure.
That would be scary, right? So
Yeah.
some people like Elon Musk could say that, okay, it is like they're saying that AI is coming, but by the time that you see that AI get to that level, you
Mhm.
cannot see anything else. It just those are going to be very intelligent machines that they
Right.
can do
That's
us more
Rehoboam. That's
than human.
Westworld. Rehoboam talking
Well,
about.
it's the same evolution that the car, autonomous driving, right?
Right.
It's has a model. It's a bunch of individual use cases, like look at a person, look at a street light, look at whatever. Now they're all combining together to where people are feeling confident that, yeah, we'll have a true self-driving car by such and such a date. I saw a Waymo going down the street. Still got a person there in the driver's seat, but his hands are off and he's just there. But it's pulling up, it's stopping, it's going, it's dealing. Yeah.
I mean, we just saw that last night on the Super Bowl. I don't know if you saw the Super Bowl commercial with Edward Scissorhands. Did you see that one? The
Oh,
new
yeah.
Cadillac. Yeah, I was like,
Yeah, but he was still pressing a button or something on this, console.
okay, yeah, you got to press the button. But other than that, it was pretty self-driving. It seemed in my
Right.
mind.
Interesting.
So there'll be so whenever you say it's scary, are you talking about just at that point you can't control it, or like what?
That is what everyone is talking about, right?
So that's a real possibility with this deep learning and the multiple layered. Okay, interesting. That's the first I've heard of that. So
and then there are some other models. So that the deep learning model, most of the models that we are talking about are supervised model, right? So you
Right.
have to have input and output. And then there are the new generations of the models. There are lots of researchers focusing on the reinforcement learning. Reinforcement learning has been there for quite some times as well, but it doesn't need a specific output. It needs a specific output for a specific task over the time, right? So for example, navigation, right? If for example the car from the one location goes to that the final location, that is, for example, some rewards that they gave to the model, right? In between the destination and then where you are right now, there is nothing else. So you don't get any rewards. If you get rewards only when you get to that location. So that would reduce the amount of the training size a lot when you are doing that. The same thing that, for example, the Google Mind DeepMind is doing, for example, training some machines in order to play chess or play alpha, right? So the model only get the output when it win the game, right? Otherwise, you never know that if the model is doing good or bad, right?
Right.
So that there are lots of
that's how you reward an AI, by winning.
right. Yeah, the people talk about it. For example, when you are training your dog, right? When you train your dog and then give it treat, if the dog doing whatever you want, that is only things that the dog is getting, right? In between, the dog doesn't get any other things.
Mm-hmm. That's wild.
So how do you reward a machine model in oil and gas?
That is wild.
Give them money.
Oh my goodness. Oh, that's good. Well, I know that, when we talked about the machine models that we're working on with Clean Connect, you said, yeah, you use deep learning in all of them. So I was actually surprised by that, because we think of drawing, around images and saying, hey, that's a tank and that's a level, but there's some deep learning going on beyond that.
Yeah.
I don't know how that works exactly, but.
So think about it, for example, when you have one image, that is the image of the tank. I make it very simple. and then you have the level as output, and then you create thousands of these samples. Say that, okay, if this is the tank, and then human can look at it and say that this is the level, and then say that, okay, this should be the output. And the model try to map these two together, right? So the model get the image of the tank, generate some output, right? Let's say randomly, right? That output, you can calculate the error between what should be the actual output and then what model is predicting, right? That error back propagate to the model and then change some parameters inside the model. Again, new model, new data is coming, go to the model with the new weights or new parameters, generate some output, and then the output probably is not close to the actual output, but we have that error, and that error change some parameter inside the model. And then we do it over and over and over again in order to make sure that if there is a new image, we are very close to the actual output. And then when we plot the error meaning that what model is predicting and then what is the actual output, can the error start to decreasing. And then that is how we know that the model start learning the relationship between the input and output.
Okay. That's wild.
I'm still a little bit lost on the deep learning part. Like that sounds like the regular structured learning part. Or
Yeah,
I get, but
the deep learning part, so you can have different models in order to do that. You can have, I don't know, the random forest or decision tree or SVM or the other things inside the model in order to do that. When you try to, for example, train random forest, you have to give them those features that you think are important. Right? So you have a little bit think about, okay, in this image, I think for example, the actual difference between 2 pixels around each other is important. So you calculate that and then give it to the model, for example, as a one features to the decision tree. You may think that maybe, for example, eigenvalue or eigenvector of the image would be important. So you have some knowledge about the actual data. When we are talking about the deep learning will create all of those features for you, right? So they may come up with some random features that people may not think about it, but when we have different layers and then we have the image, that image goes to the neural network. Each layer is generating some features, and those features goes to the next layer. Those next layer combine all of those features, come up with the new features, and then that is hierarchical learning. That the model is creating some of those features by itself in order to map the image to the output.
Right.
Right.
No, I'm following that.
The good thing about the deep learning, beside that, is you can increase the size easily. You can train it, right? So some of those models, the classical model, they cannot get, for example, tens of millions of the images. After maybe 10,000 image that you give to the model doesn't change anything. It just stick into we call it local minimum, right? So it cannot change anything. So it cannot have the capacity of learning that many data points. But because the way that deep learning is structured based on some of those nodes, you can add more nodes to the deep learning. You can create a new structure of the deep learning and then keep continuing learning from the data.
Right.
So it doesn't, the model doesn't saturate and then continue improve the results.
Incredible.
Very incredible.
So it sounds like the difference is one of them you're really having to coach it along, right? And on one of them it's like more like a kid where you let it. I mean you, like for my children, I if my kid falls down and hurts himself, then he's learned from that, right? And it's not that I didn't tell him like, hey, don't jump off the coffee table, but whenever he eventually does it anyway, he learns that himself and eventually stops. So it's kind of, it's more like training a human opposed to just a if then this type of scenario is what I'm
So that is very close to what you explaining related to reinforcement learning.
Right.
In the reinforcement learning, we are using the deep learning as well. So it's much broader concept, but similar to the kids that they get reward or they get punishment, right? So if they fall, they get punishment. Maybe they hurt themselves, or that pain stop them doing that again. Or for example, if they do something good and then you give them the reward, they try to continue on doing that again and again, right? So that is more related to concept of the reinforcement learning.
Okay. Wild.
Well, I don't know how deep I am at learning this stuff. I think I need more deep learning to learn deep learning. Anyway, well, Mehdi, I appreciate you sharing this. And if you think of any links to deep learning, we'll include those in the show notes as well, so people can do further reading and whatnot. Okay, well, thank you, everybody. And I appreciate Mehdi taking the time to give us Machine Learning 101. Maybe this is 102, right? Appreciate it.
The service.
Thank you. Thank you for
Thanks,
having
guys.
me.